Hey there, my name is Alejandro and welcome back for day 12 of me doing the NeetCode 150 challenge. So today we're doing a trees problem and let's get straight into it. Okay, problem 104, maximum depth of binary tree. LeetCode easy. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest least node. Okay, so for example here we have 3, 9, 20, 15, and 7. So the output is 3, right? Because, okay, the height of the tree is essentially 3. Okay, this is actually relatively straightforward. Essentially, we can keep track of a depth every time that we make a recursive call, right? So essentially here we can call return self.max depth helper with with the given root and an initial depth of 0, right? So essentially it's like here we're essentially going to say, okay, max depth helper is going to take a root and a 0 and a depth, right? And then it's going to be like, okay. We can also have, you know, like an easy way we can do this. Okay, let's do things easily for now. So let's have a here, we're going to do an init. So we're initializing a depth to be equal to 0, right? And so here we don't even need a helper. So it's just like depth is equal to self.depth or so on. And it's like, okay, if not root, return self.depth. Right? So we initialize this to be equal to 0, right? So if not root, you know, the root is none, we return whatever self.depth is. Initially it is 0, so if the entire root tree is nothing, then we have a depth of 0 at the beginning, right? Otherwise, what we're going to do is essentially, we're going to say like, okay, self.depth plus or equal to 1, right? Or actually, we do need a current depth, right? Okay, so maybe we do need a helper. Let's go back to our initial thoughts here. Right, so the point is something like this. If not root, return depth, right? Left is equal to self.max depth helper of root dot left comma depth plus 1. Right is equal to self.max depth helper of root dot right comma depth plus 1. Return max of left, right, or depth plus 1. Does something like this work? Okay, let's run this. Once it lets us, okay. Takes 2 positional arguments. Yeah, I give this a root and a depth. Oh yeah, this is supposed to have a self here. Okay. Okay, so this is accepted. Okay, beautiful. Right, so here we can submit. Okay, there we go. And first accept the solution. Okay, so the idea essentially here is that every time we go through a root, we're essentially going to pass the current depth, right? And so like, if not root, then we return the depth. Otherwise, since root is valid, then our current depth plus 1 is going to be our new depth, right? In fact, okay, these are the very minimum. If left is none, it will return its own depth of depth plus 1. So we can actually remove this from the maxing result here, right? So something like this will work. Right, and so this is why I'm wondering if I can do something like this. If I do def, def init is going to be equal to self.depth of equal to 0. And here, if we can do something like if not root, return self.depth. Otherwise, return max of Otherwise, self.depth plus or equal to 1. No, that's why we need, okay, we can't have each recursive call plus or equal 1 if there is a depth to be had, right? Right. So yeah, we just need the the helper like this. Okay, I'm trying to think of like a more efficient way to do things and so on. But honestly, this is a pretty good way to do things nevertheless, right? If not root, return depth. Otherwise, yeah, return the max of these two. I'm trying to think. Okay, can we do something better? Are there any follow-ups or anything like that and so on? No, there are not. I'm trying to think, right? So this makes sense. We start with a depth of 0. Maybe without the metadata and so on. So it's like, you know, we keep track of like a stack. Ooh, we could also try to do this iteratively, right? So if we do something like this, we initially have root as our stack. Depth is equal to 0. Stack is equal to root. Okay. If not root, turn 0, right? Depth is equal to 0. Depth is equal to 0. Stack is equal to just root. Root with a depth of 0, right? While stack root comma depth equals stack.pop. Max depth is equal to 0. Max depth, return 0. Equals stack.pop. Max depth is equal to max of max depth comma depth, right? If root.left, stack.append root.left with depth plus 1. If root.right, stack.append root.right with a depth plus 1. And here return max depth. So something like this, does it work? It does not. So I'm off by 1 here. Ooh, let me think. Okay. All right. Right, so the point here is that we got to root, right? So if not root, then return 0. Otherwise, root itself is a valid node. So this should actually start at 1. And it doesn't matter that we have this as 0 because we have the max stuff here, right? Yeah, okay, so that makes sense. And now we can submit. Ooh, and 98%, okay. Iterative solutions for the win. Okay. Let's get rid of that. Let's get rid of this. Okay, so this one made sense and so on, but it feels good every time you can get an iterative solution. Trees are my favorite data structure to write recursive solutions in because they're just so naturally recursive and so on. But whenever you can get an iterative solution, you might as well, right? So, well, generally the rule of thumb, at least that I get for myself, is that if you can write an iterative solution over a recursive solution, you totally should, as long as you know it doesn't make things overly complex and so on. And this problem, it doesn't. It makes it nice and sweet anyways, right? Okay, so 98%, very nice, bada bing, bada boom. But otherwise, as I do in all my videos, I like to do a quick recap of how I was able to solve the problem. So in this case, we essentially want to return the maximum depth of the tree, right? And so the very first solution that I wrote, here I can maybe control Z a little bit, is essentially I had a helper here that I initialized with the initial root of the tree and a depth of 0. And the point is like, okay, if the root is none, right, then I return whatever the current depth is, right? Because again, that's the end of that path or tree and so on. Otherwise, I will get between the left and right children, they might both be none, in which case, like, you know, the depth is depth plus 1 and so on, because we have that root node that counts as that plus 1 and so on. And then between the left and the right, you know, like, get the max depths from that one, return the maximum of those two, right? And so that's essentially the recursive solution. That one is pretty straightforward, where it's just like, literally just like, okay, return 0 if their initial root none is none. Otherwise, you know, you have at least a height of 1 because the root is valid, and then just keep going, like between the left and the right, you know, depth plus 1 as their initial default value and so on. If this is none, this will return depth plus 1. If this is none, this will return depth plus 1. Otherwise, you know, it'll return whatever is the longest path and so on. And between these two subtrees, return the one that had the highest overall depth, right? But otherwise, once you understand that concept, I also wrote an iterative solution. So this is just very nice, right? So essentially it's like, okay, if not root at the very beginning, then I return 0, right? Otherwise, essentially, I start off with a depth of 1, right? Because I know that I have at least a root node that is not none, right? So I have at least a height or a depth of 1, right? At least the root node itself, right? And then from that point, I have everything in a stack. I start off with the root node in a depth of 1. And while the stack is non-empty, essentially I like pop whatever's from the stack, right? And it's like, okay, whenever I pop something from the stack, I pop a node and its depth, right? And then it's like I update my max depth to be the max between the current max depth and the depth and so on. That makes sense. So it's like for every single root that for every single node that I will visit in the tree, I will know its node and its depth value, right? So update max depth to be the max of those two things, right? And then all I'm doing here is a little bit clever. So if root.left, right? So if root.left is not none, then that means it's like, okay, I can do depth plus 1 on that side, and then I can try to recursively get more and more of its depth as I go on, right? So I will append that to my stack so that I can essentially visit that node and check if that one also has children in this exact same way, right? And the same thing I do for root.right. If root.right is not none, then I append it to my stack with depth plus 1, right? Because this current root node here, I guess I could call this a node here, right? So maybe this would make more sense if I call it node like this, right? So it's not always a root. Well, it's a root of its own subtree, right? And so on. But the point is I have a node here, right? And if the fact that we visited this node with depth of depth, right? If it has a left child, that left child node, i.e. node.left, will have a depth of this node's depth plus 1 because it's 1 below that depth, right? So that's why we assign that node a depth of depth plus 1, right? So this node has a depth of depth, right? Starting with the initial root node, which has a depth of 1 because we have at least a root node, and so the height of the tree is at least 1, right? And so for every node, again, its left and right child, if it exists, will have that node's depth plus 1 because it's 1 level deeper than that node value node. So I hope that kind of makes sense. And then again, it's just if node.left, then append that to the stack. If node.right, append that to stack. And again, I will always continue as long as stack is not empty. And for each thing, again, like if I append to a node inside of the stack, when I visit it and so on, I will also check if that has left and right children. And if it does, just keep incrementing that depth and so on as I go until I get the very maximum depth and return that value, right? So that's essentially how I was able to solve this problem. And yeah, we get a very, very, very efficient solution of 98.33%, which is absolutely excellent. So as always, in these videos, I will always make sure that I check off the right box for having done today's NeetCode challenge problem. I need to start saying in my videos, in case you want to see the full breakdown of the schedule of me solving these problems, I have it pinned down below as a comment in the comment section. So I put a green check mark next to the problems that I've already solved, including this one today, the maximum depth of binary tree. But in case you're curious of when's the next date that we'll solve the next problem and so on, or more importantly, the order that I'm solving the problems in, since I know, like, for example, yesterday it seemed maybe kind of, not yesterday, but the day before, I see maybe a little bit random, like, oh, why did I go to this LeetCode Easy instead of like one of these mediums and so on, or why am I skipping so many of the problems in this subject? Essentially, I'm just doing all the easies of every section, then all the mediums, and then all the hards. But pinned down below in the comment section of every single NeetCode 150 challenge video, I will also list the full breakdown of the solutions, the schedule, and each and every single date that I will be solving a problem in, and the name of the problem that I will be solving on that date. In fact, the very last day I believe that I will be done with this NeetCode 150 challenge will be on September 12th, 2025. So I'll just start making sure that I say that at the end of my videos, hopefully not as long as in this video and so on. This is the first time I do it. But yeah, in case you're curious about the schedule for the NeetCode 150 problems, it's just pinned down below in the comment sections. But otherwise, that's pretty much it for this video. I hope that you found it useful or enjoyable. And if you did, I would highly appreciate it if you left a like or a comment. And otherwise, I will catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.